Hello everyone, my name is Twan from CS Schools, and in this video we're going to go through a sample solution for question 5 in the Sample Written Examination 2 for VCE Specialist Mathematics, and it is focused on pseudocode. In question 2, it says the algorithm below, described in pseudocode, estimates the value of a definite integral using the trapezium rule, and we are provided with an algorithm in pseudocode. It then asks us to consider the algorithm implemented with the following inputs, and then asks us to find the value of the variable sum after one iteration of the while loop. So if you haven't already, please watch the first video in this series as it covers some of the pseudocode concepts that we're going to go through in this video. And also, please check out our successful pseudocoding course for additional information and exercises. You can find that at csnschools.io/pseudo. So here is the pseudocode that they've provided for us. And this question involves the concept of a function in pseudocode. Let's quickly compare how a function works in pseudocode with how you might understand it in mathematics. So consider this function in mathematics. F of x is equal to x squared plus 4x plus 3. So this function has a name, and the name of the function is f. This function also contains a parameter, and in this case, the parameter of this function is x. And the function has a body, which is x squared plus 4x plus 3. Now, these three terms are going to also be applied to the concept of a function in pseudocode. Altogether, this is called the function definition. And in mathematics, to evaluate the function for a value, we can say that we call the function with a specific argument. So let's say f of 3. So the 3 in that case is the argument. And what happens next is that we take the value of the argument and we substitute it into the parameter that we see in the function definition. So what this means is we take the 3, we substitute it in for x, and that means anytime we see x, we use 3. So let's take a look at how functions work in pseudocode, and you can see that there's a lot of similarities. So in this case, we have a function that's defined for us, and the name of the function is trapezium. And you can tell what the name of a function is because they are the letters and symbols that you find before the brackets. And these are the parameters of the function. In this case, we have 4 parameters: f of x, a, b, and n, and they are separated by commas. The body of the function in this case is a lot bigger than the x squared plus 4x plus 3 example that we saw before. In this case, it involves many variables, it involves assignments, it involves a loop there, but it's still considered the body of the function. And altogether, the whole thing is called the function definition. So to evaluate the function, we call the function with specific arguments. So we use the name, just as how we did it before with f of 3. We're going to use the name trapezium, and we're going to fill it in with 4 parameters in this case. Here we have sine of x, 0, 10, and 100. And what happens next is we take those arguments' values and we substitute it in for the parameters in the function definition. So f of x takes on the value of sine of x, a takes on the value of 0, b takes on the value of 10, and n takes on the value of 100. So let's go back to the question here. We are asked to consider the algorithm implemented with the following inputs. So those inputs are basically the arguments. We are going to call the trapezium function as indicated by its name. These are the 4 argument values that we are supplied. So what we're going to do is substitute them in for the parameter variables in our trapezium function. So how we're going to handle that is we're going to construct a trace table. And once again, please refer to the previous video where we introduced you to trace tables in the context of these questions. So what's going to happen is we're going to take the parameters in the function definition and set them up as variables on the left-hand side of the trace table. So you can see there f of x, a, b, and n have been constructed as rows for themselves, and they have been filled in or initialized with the arguments that were used when we called the function. So the first argument was the natural logarithm of x, so that gets assigned to f of x. The second argument is 1, so that gets assigned to the second parameter of a, and similarly b gets assigned to 3, and n gets assigned to 10. So having set up those variables, we are now ready to go through our function one line at a time and see what happens. So in the first line, you see this little back arrow. So in pseudocode, sometimes the back arrow symbol and the equal sign are used interchangeably. They both indicate assignment. The previous video discusses how assignments work, but generally you always look at the right-hand side first, you evaluate the expression, and then you assign it into the variable that you always find on the left-hand side. So let's do that now. We're going to set this up as a new row in our trace table. The variable h has been inserted, and the entire expression has just been put into the value column for now, b minus a, all divided by n. So what happens is we're going to substitute the values for those variables using what we find in the trace table. So b gets substituted for 3, a gets substituted for 1, and n gets substituted for 10. So we plug them in, we evaluate it to 0.2, and that will be the final value that we assign to h. So that line is done. We move to the next one. So here we find that sum is going to be assigned the value of f of a plus f of b. So let's set that up in our trace table and begin to evaluate the expression on the right-hand side. So f of a plus f of b, what we're going to do is substitute in a and b into those function calls. So that's f of 1 plus f of 3. Now we know that f, the function, is the natural logarithm of x when we consult the trace table above. So that's really saying the natural logarithm of 1 plus the natural logarithm of 3. So if we evaluate that with our calculator, we arrive at the value of 1.099 to 3 decimal places. So that will be assigned to the value for sum. The next line is a plus h is going to be assigned to x. So there's our x variable, a plus h, substitute in our values, and we get 1.2 being assigned into x. And then we just have 1 being assigned to I, so there's I and 1 right there. So now we come to this next line of code, which is another loop. So you may have remembered us using the repeat loop in the previous video. This one is a slightly different kind of loop called a while loop. So the way that a while loop works, it's similar to how a repeat loop works in that the code that is indented and underneath it will be the section of code that will be repeated. So you can see that code there highlighted in red. However, unlike the repeat loop, there isn't a predetermined number of times in which we will repeat the code. So we don't know in advance how many times we're going to repeat that section of code. So to determine whether or not we repeat the code, we always look at the expression that follows to the right of the while keyword. So in this case, it's I less than n. And that expression will always evaluate to either true or false. So let's see what that gives us. So let's plug in the values. I is substituted by 1 and n is substituted by 10. We now have the expression 1 is less than 10. Now that expression will only give us a true or false answer. In this case, 1 is less than 10, so it's true. Now when the expression after the while statement is true, we are going to go inside the loop and execute the indented lines of code. So it's true, so we're going to go into the indented block of code. And just like in the previous video, we're going to go through the lines of code one at a time. So let's do that. So the first line of code there is assigning sum plus 2 of f of x into sum. So let's substitute in our values. Sum we had from before, which is 1.099. F of x, well, x is substituted by 1.2, and f is substituted by the natural logarithm. Plug that into our calculator, and correct to 3 decimal places, the answer is 1.463, and that gets assigned back into sum. So you can see there the sum value has changed. The next line of code is updating x. It's adding h to x and then assigning that back to x. X is 1.2, h is 0.2, so the answer is 1.4. That gets assigned back into x, and x is updated to 1.4. And then the last line of code there is adding 1 to I and assigning that back into I. So that's 1 plus 1, which is 2, and then that goes back into I, so I goes to 2. Now, the last 3 lines of code illustrates why the assignment operator in pseudocode is not the same as the equal sign in maths, even though they are related. Because let's take a look at that last line and rewrite that and consider it from a mathematical point of view. I equals I plus 1. Now, that's clearly not correct from a mathematical perspective, unless if I was infinity, of course. So it's just a small point to keep in mind that in pseudocode, the assignment operator is not the same as the equal sign. Anyway, so we've done those 3 lines of code. We've just completed 1 iteration of the while loop. And if we consult our question again, it's asking us for the value of the variable sum after the 1 iteration of the while loop. So we've done the 1 iteration, so we can now arrive at our answer. So let's look at the variable sum, look at its value, which is 1.463, correct to 3 decimal places, and that will be the final answer to the question. Just to wrap up this little session, if the question didn't ask us to stop after 1 iteration, what that would mean is the code would continue. And in this case, with a while loop, when we've finished the indented line of code, we would always go back up to the while condition and we would re-evaluate that Boolean expression. And in this case, if we were to do that, we would see that I has now changed from 1 to 2. 2 is still less than 10 if we plugged in those values, and so that condition is still true. And while that condition is true, we're going to go back into the loop and repeat again. So even though the question is only getting us to do it 1 time, in general, the way the while loop works is that it's going to continue to repeat that section of code as long as that condition is true, or while that condition is true, hence the name while loop. So we'll go through an example with multiple iterations another time. Thank you for listening to this video. Once again, please jump onto our website, csnschools.io, for additional content and materials around pseudocode.